All right, everybody, we will go ahead and get started here in about 10 seconds. Just let a couple more people file in. Awesome. So, yeah, super happy to be here today. We're going to go through a very intensive webinar with focusing on LiPowerline. I'm going to be with my special guest here, Ted. Ted, if you want to go ahead and introduce yourself for any of those who don't know who you are.
Hey Cody, it's great to be here. I love LiDAR, so let's get nerdy with it. This is actually really, really cool stuff and seemed kind of out of reach when I started in the drone industry like 8 years ago, and that's what I do is essentially drone services. And really excited to take everybody through the walkthrough that I experienced myself recently with LiPowerline.
Absolutely, yeah, man. Super happy to have you here. Again, the software is absolutely incredible when it comes to live Powerline. When it comes to Powerline work and the efforts with Powerline management and asset management. So, without further ado, we'll go ahead and jump straight into it. We got a lot for you guys today, so stay tuned.
Yeah. So I guess let's start where we kind of picked this up most recently, and that was like a day in the field together that we shared a couple weeks ago. And we also had that opportunity to try out the M400 for the first time, and Grant from DJI was with us there as well. We had a whole day with the system, and you brought some toys. You brought some really cool sensors, and this is a clip. I was following the M400 here as it was doing a transmission line, and you can see the rotating LiDAR in the bottom there, and that's the X4 that will show some data and examples from today. Yeah, so this is the product line. Cody, you shared this with me. This is part of the GreenValley product line. You guys have been in the field for a while, and you even GreenValley does services as well, so they really understand the field work, what the operators encounter in real world scenarios. Can you talk me through kind of what the differentiation is between these three sort of key products?
Yeah, absolutely, man. So, as mentioned, we've been in the industry for a long time. We do provide services in certain regions, and one of those key factors is power line asset management. We put a hyper focus both on our software side and our hardware side when it comes to power line management. So, everything across the board, starting from left to right, we have our H1500F. This is mainly focused on helicopters or fixed wing aircraft for extended flight time, good penetration, good quality results at around 1500 meters, full waveform as well. And then moving on over to our latest release of the H600. This is more designed for your eVTOL or your UAV system. It still has a high long range at 750 meters, and it also provides a full waveform. This is one of the products that we'll be highlighting today. And then moving over to the right, we move into the LiAir series. So we started with our LiAir V40 back in the day, had our V70, and then our X3, X3CH, and onto our X4. The key component with the X4 is the level of autonomy that the system provides when coupled with something like the M300, M350, and M400. The system is capable of doing autonomous power line following, tracking, active measurement, and that's some of the things that we'll highlight. It utilizes the Hesai XT32M2X, so it has a range of 300 meters. It also has a handheld system that provides panoramic imagery, also the Gaussian splatting 3D GS within our software. So you get a really full picture of the power lines from above and below when it's absolutely necessary for that fine inspection side of things.
Yeah, what impressed me about this is just, and this is sort of a characteristic of the Liair product line that I've used and tested in the past, but it's a very versatile system. So you could mount it on a UAV. You can see here the DJI port directly, and it gets power from the vehicle, and then also handheld mode to do your SLAM or RTK GPS aided SLAM. And then, of course, cameras on board for both the downward facing when you're flying and looking at the power lines, for example, and then cameras on the sides so that you can create those cool new 3D products like splats and whatever we'll have in the future. Because really it all just blends together at the end of the day. It's all spatial reality capture. But what I think is kind of exciting and kind of like the where we're at in the industry, and I've been tracking this for a little while, is this like relationship between the old school, big payload, big vehicle, helicopter, for example, in this case, is very long range lasers, and then we're kind of seeing that blend into the UAS space, into the uncrewed space with the H600. The cool thing is that these are now in the category of lasers, which works on the 1550 nanometer wavelength, and that allows this range number to really shoot up. And we're going to see more and more of this becoming the norm in the industry, I think, because there's a lot of benefits. And there's a lot of benefits also to having full waveform. And for those in the audience that may not have heard this term before, essentially what it means is that you're getting the raw laser return data, as opposed to the traditional lasers that we're used to in the UAV industry, where you're getting discrete returns. So they're essentially limited and filtered by the scanner, and you're getting three, for example, right? Top, middle, canopy, and then ground. That could happen. But when you have full waveform, you actually choose which returns you want to keep, because the reality is all of these lasers are seeing more than three, but it's being sort of filtered down unless you have the full waveform. And so I think the H600 is capable of like 7 to 8 returns, I believe.
Yeah, as the standard, it's set at, you'll see 10 in the software, but
Mhm.
accounting for noise, you're looking more at around 7 returns or more.
Yeah, so you kind of like choose your own adventure too, and it also depends on the flight parameters, the speed, the height that you're doing. Of course, you're going to be a little bit higher in this case because you can, and that may produce more noise. So some of those returns may be not useful at all. But the thing is that if you want to, you could go down there and find those very very last or second to last returns and make use of them if they happen to be reliable. And I think that's like a big factor here. Of course, the amount of data created is also going to explode, right? Like there's just so much more information in these files, so you have to be careful, but you have that flexibility, which is awesome. And also, a system like this could go into a fixed wing platform very well, because you're getting such high point density, and you can move fast and still collect a ton of points under you, while still getting RGB as well. So really, really cool. I'm super excited for this category to just really become the norm. And these scanners will still be very relevant, I think, because they have features like the rotating head. And that's from what I saw on your website. That's something that you guys have worked on a lot over the years. And having that laser head rotating gives you a very large field of view, a lot of points all across you. So that's why it's the system that you're going to want when you're running handheld. So you don't have to swing your hand around and cover everything. It's just doing that for you. The other cool thing that I saw on your website about these two systems was that the GPS antenna is optional. So usually with GPS and or GNSS and LiDAR, you have the payload, and then you typically see some sort of mount with an antenna sticking out of it. That is part of the INS system and the whole POS system, so the positioning orientation. And well, the aircraft, the M400 or 350 here in this example, they have GPS antennas too. So now you're able to actually make use of that through the SDK, the onboard SDK, and all the payload SDK features that enable you, which makes things even simpler to set up. You literally just plug it in, click it in, and you're set to go, right?
Exactly.
Yeah, it's and I mean with this transmission and power line stuff, like it can get pretty raw out there in the field. Like I have a friend, his name's Chris. He does some incredible work, but they are in very remote regions. So you want to have your kit as simple as possible, as reliable as possible, right? And so these are the little sort of incremental iterations and updates that we're seeing on these systems that are making that more and more true, and much easier for operators to handle these long days in remote regions collecting this data. Got some data to peek through. So here's an example with the H600. Really cool, really, you can tell it's really tight, really, really nice returns, not too much noise. You can very clearly see the elements of the structure. You can see the insulators, conductors, the shield wires, the actual truss structure as well. We could explore this a little bit more if we open this up and near I uploaded the classified point cloud here. And anyone that saw that QR code, you can actually open that QR code up as well. I'll put it on the screen in a moment. And you can zoom in and explore this. And you can see here it's being classified. And most of this classification is completely automated, right? So the GreenValley software suite with LiDAR 360 and with LiPowerline now has some extremely solid automatic AI-based classification of point clouds, which in the early days and when I started sort of looking into this maybe 3-4 years ago, that was a huge bottleneck. You needed to have very specific skills and software that was macro based, and it was not approachable. But I've been able to create classifications just like this one with multiple types of data sets from different sensors, the wing truss sensor back there, handheld sensors, and it works really, really, really well. It's really impressive, and it cuts down on a lot of the time required in post-processing.
Absolutely, yeah. And with the advent of the deep learning side of classification in LiDAR 360, for instance, the users can actually train our software to make it as accurate as possible with their own data. So they can train the software using our deep learning training model, which allows for the most detailed results in any situation. So it's not just based on the training data that we've done, they can also train the software themselves.
I'm clipping through the different views here of the point attributes. And one thing that stands out to me with these 1550 nanometer scanners, they're a single line scanner, if I'm correct, right? So this is you'll see this characteristic pattern of the lines stacking up in the direction that the vehicle is moving longitudinally, and it's right away when you see this, you can almost assume that it's this type of payload that's being used, and it creates really, really detailed and high quality point clouds. Super pumped about these systems becoming mainstream as the industry grows. So moving on from that, here's another example you shared. You actually collected this in British Columbia. I think, was it a M400 or M350 in this case with the H600 on?
Actually, this was the M300.
Yeah, sweet. So these systems are they're pretty much self-contained, right? Like you just give it power and GNSS and you roll, right? So it's super cool that way. Let's take a look at this data set. And the one thing that I wanted to kind of highlight here that stood out to me is the penetration ability. So because you have so many returns and that laser is of sort of a higher quality, higher strength, these 1550 nanometer lasers used to be considered really exotic back in the day. I mean, up until recently, really. But now that they're becoming more available, you can penetrate through some very heavy foliage. You see here, and the environment in British Columbia, a lot of terrain, and then also just a lot of very dense forested areas where these utility and power lines are moving through. And being able to classify ground is essential in these workflows. So this gives you a chance to go right through this bush, and it's actually really crazy to see just how much we're getting on the ground with those 7 returns in this case.
Absolutely. And yeah, this scan was all of about 7 minutes or so with the H600. And as you mentioned, the level of penetration is so great that it stands above any of our systems that we have previously released in the past. So not only is the H600 good for power line scanning, it's also great for forest penetration. Utilizing something like LiDAR 360's ALS forestry module, you can get segmentation, tree counts, heights, diameters. All of these are factors that are essential when utilizing something like the H600.
Yeah, and like good data in equals better data out in that PDF report eventually, right? Because everything always goes to 2D somehow, and we have to figure it out on the way there. I'm leaving this screen here. If anyone in the audience wants to scan this QR code with their phone, they'll be able to access this data set as well. And when you do access it, what you can do to switch through some of these views, over on the top left here, there's a little drop down. It should say base settings, but if you click on it and then click on classified ground, I've set up a variant of this data set that has filtered out the low vegetation and high vegetation classifications, and you can see the ground points, ground classified points in brown there highlighted. Um, so that's
Yeah,
that link
and the
right
the
there.
beauty about this system is that this is the system directly processed from light georeference, our pre-processing software. There's no additional cleanup that has been done to this data. Any of the data that you're seeing actually has had no additional cleanup. So this is as it comes from the system after processing in our free software light georeference that comes with the purchase. You get results like this that can easily be put into LiPowerline to begin your processing and your asset management.
Yeah, and the outputs, they're all kind of handled in that software stack as well. The reporting, as we'll go over, we're going to go over like the workflow because I think it's really important for people to see just the steps because it's not rocket science. It's just a series of sort of operations that make sense and they build on each other. But at the end of the day, it's also able to export an LAS file, like a traditional ASPRS LAS file with classifications and all of those things. And that's what I did here. I literally just dragged and dropped it into the Nira uploader. And full disclosure, I do work for Nira as well, so there's a bit of a plug here. But the reality is that all of that information is attributed within that data set. It's really just like a standard LAS data set that you expect to see from any other source. The other thing I wanted to highlight here is just how consistent the point returns on the conductors here is. I think in some cases with the rotating lasers, you may have some areas where you have a little bit less density on these wires, and that has in the past been problematic, especially when you're vectorizing these wires, when you're sort of drawing them out. If there's a gap, it may not sort of connect the two ends. But the LiPowerline software we're going to show in a bit actually has a full-blown feature just to help with this, to patch those lines together. But again, if you have good data in, you don't even have to worry about these things. You just essentially click through the motions and boom, you have the resulting information that you need. All right.
Yeah, absolutely. The interactive patch feature is it was added in version 8, so released in October. It's made a huge difference because the terrible side of traditional scanning in the past is driving 4 hours away to do a scan and finding out that the collection was not as good as possible and you're missing some of your line data. Traditionally, there was not much you could do. You could attempt to manually draw vector lines, but it was so inefficient if
Mhm.
you're doing 10, 20, or 100 kilometers. So the new interactive patch feature is huge.
Yeah, painful clicking in front of screens for hours if you don't have the right setup. Going back to our day though, this was our morning. You came over to my place. We got ready to head out to our first location, and then we had to figure out how to mount this because the M400 was so new. This was like the day after it was announced that we didn't really have the bracket for the GPS antenna set up yet, but this kind of goes to show the simplicity and like versatility of the system. It just plugged in, boom, the M400 fed it power. There was no sort of additional firmware we needed to change or anything like that, just the stock DJI firmware. And then we just zip tied this GNSS antenna right on the gimbal mount, and it worked. Like there's really there's a few ways to do this. Like it's not going to be survey grade, and we didn't really care for that. We just wanted to collect point clouds. But that was really cool how it kind of just strapped together, and boom, we had a point cloud later on. And in fact, during one of these flights, you didn't even use GNSS base. We didn't do PPK with this. It was just directly georeferenced from the sensor, which I think is really cool. Of course, it's not going to be the best result, but if you're in a pinch, being able to do that is very important.
Absolutely. And with the software like LiDAR 360, if you have ground control points set up, you can use those control points to georeference it geospatially. So even if you run without a base station, say your base station dies or
Mhm.
something terrible happens, you can still get your data processed.
Yeah, right on. The georeferencing is a whole other sort of can of worms, but at the end of the day, it's part of the procedure, so it shouldn't be skipped or sort of overlooked. But in the examples we're showing, we're not really attributing anything to absolute coordinates. We're just dealing with the point clouds, so we won't be talking much about the actual georeferencing portion of the workflow. Now the
Absolutely.
X4, the one that you saw mounted on the M400 there, that has this additional capability that we talked about earlier, which is sort of the autonomy aspect of it. And this is a screen recording from the controller, which from the looks of it is a GreenValley app that runs on the RC. And it takes over full sort of control of the flight control of the aircraft and of the data that's streaming in as you're flying, and it's autonomously following the lines underneath it. Can you kind of walk us through like what we're seeing here?
Yeah, so this is Green Valley's software live plan. As mentioned, you just added to the DJI remote. It's a free download. What we're seeing right now is the FPV from the drone itself, along with the real-time point cloud, colorized point cloud, being visualized on the remote itself. We can see the parameters of the system, and also if you notice the yellow lines on the right-hand side, that's real-time tower marking as the device is flying. So it's actively marking the towers and saving those files as
Mm,
a KML file inside of the remote itself, all in real time. The
nice.
other beautiful part about this is, so we were following a distribution line, a single
Hmm.
distribution line at about 15 meters or so above the line. And the key factor that you had mentioned earlier with the rotating head that makes the difference between something like the H600 is the level 4 autonomy that the X4 provides when coupled with the M300 and 350 M400. So traditional sensors do not have the ability to see upwards from the device itself. So it was limited in any type of crossing line situation, such as scissor crossings. This system was able to automatically detect those lines, those transmission lines that it crossed, automatically fly to a safe height above that, as seen in this image here, and continue its flight on while staying locked on to the distribution lines below those transmission lines. And as you can see, the trajectory that we're seeing started off following the distribution line, came across the first set of transmission lines, which was at one height, and it decided to fly up. Then it came to a second set, and it decided that that one was slightly higher, so it flew up. Then the third line was also slightly higher than the fourth one, the second one. So all of these were automatically, autonomously decided by the system without any interaction from the pilot, which was myself. So myself and another individual. At the time of the flight, the system just indicates that it has noticed a crossing line. It automatically flies up and then it continues its path. Once it's safely past the transmission line, it will automatically come back down to the designated height above the original distribution line and continue that flight along.
Yeah, what stood out to me is just how closely it's following this distribution line. You can see here it's 14 and a half meters above it approximately here on this tower. And then when you look at it from this profile view, you can see that that contour is just hugging it across the entire distance. And then as soon as it detects these crossings from these transmission lines, and these conductors have several levels. This is really cool how it's picking that up and intelligently making the adjustments to the flight lines and the altitude that it needs to fly across at, and then boop, right back down to where it was supposed to be. And then just checking on this height, look at that, right back to about 14 and a half meters above the tower, and continues that trajectory. Because I mean, in this situation, your focus is going to be on this distribution line, right? So this is what unlocks the ability for this type of work to be done autonomously, because there's a lot to cover. And I mean, this is a thing that's already happening in Canada. In November, it'll be mainstream essentially with new licensing. But we really need to have more efficiency in the data collection, and part of that is just the amount of workload that the operator has. It's already a long day for him or her, and having to watch a screen and just manually fly, or dealing with these flight plans that have to be pre-configured, and it's a lot of time sunk into the work before you even start to fly. And this kind of eliminates that bottleneck. Another cool thing I wanted to show you here is, I just noticed this actually. You're doing this autonomy without RTK at the moment. So you can see the RTK is crossed out. So it doesn't depend on just GNSS, because you may not have corrections out there, or you may not have a base. It's doing this just from its own solution, and the LiDAR that it's ingesting in real time as well. Super cool.
Yeah, it's purely based on our self-developed algorithms. The X4 was in works for about 2 years. We wanted to make sure that we perfected the level of autonomy. So we stand behind this product, and especially in the realm of power line scanning. This was like the main purpose behind the system. But the system soon will have a firmware release for full autonomy.
Mm, that's awesome. I mean, I'm excited to see how this space progresses because the demand is there. And so, the all the sort of market factors are driving us towards this. Uh, can this system go underneath the crossing, for example, in situations like this, or maybe something a little bit different than this?
It absolutely can. So the presets parameter settings is 7 meters. So as it approaches the crossing line,
Mm.
it will determine whether or not it is 7 meters. If it is above 7 meters, it can safely fly under the crossing lines. If it determines
Oh,
that it's higher than lower than 7 meters, then it will safely cross the crossing lines.
awesome. Yeah, because I mean, you ideally want to keep the line that you're focused on at the same sort of data quality and density throughout the whole range. So if you do have that option of going underneath, I can see how that's useful. And previously doing that with just GPS or manual flying, that can be pretty tricky. You don't want to put your system in harm's way, especially with these wires that are often hard to see. And then here's the same unit, the X4, but you scan this on the ground in the handheld mode. So I think it's perfectly viable for some of this analysis as well, because the point cloud is the point cloud, right? And just how you've created it doesn't really matter at the end of the day as long as you're getting the areas that you need. Do you want to talk about sort of how this went?
Yeah, so this was just a simple, pretty much 2.5 minute walk around scan. The main point of the scan was just to highlight the detail of the power line structure. Uh, this is coupled with an RGB imagery as well, but in this instance, we'll highlight the point cloud at height level. So we
Mm.
can see the extreme detail both at ground level and all the way up to the top of the tower. Because the system is able to spin that 360 degrees, as you were talking about, and also be omni-rotational, it gets the entirety of this tower with ease. So it is a very useful product, as we were mentioning earlier, to get the power lines from above and also from below.
Yeah, and what I'm looking for when I look at these SLAM data sets, especially of features that are further away, what I'm looking for is does this sort of region here start to break down and get too fuzzy because it's hitting the laser is hitting it at a high angle of incidence, and you may not be getting as many returns there, or they're going to be sort of noisy returns. And what I see here is very consistent, right? All the way to the top to bottom, the density across the structure and the lattice work is there, and we don't see any sort of noise in between the lattice structure. It's very tight and clean, and that's pretty incredible for SLAM. Like SLAM point clouds are tough, and I don't think there's really any sort of situation currently in the market that kind of produces SLAM point clouds that are on par with terrestrial laser scanners, just because those things don't move. And so it's just a simpler problem and more sort of differentiated hardware as well. But this kind of unlocks a lot of opportunities for more urban areas where maybe flying a drone isn't the right thing to do. And maybe having a small crew with a couple of these scanners walking around and doing this is the most efficient and safest and cheapest often way of doing the data collection.
Exactly. And as you mentioned, the fact that this is pure SLAM, again, another situation where GPS is not needed. So the system works in a pure SLAM manner. And with the handheld kit, the GNSS is attached. So if you do have access to cores, you can process the SLAM data and have a georeference based on the SLAM data as well.
Yeah, yeah. So there's an RTK little antenna on top of the system, and you're just getting corrections or from your own base or from a correction service, and you're tied in at that point, as well as control points that you can set down. QR codes up here if anyone wants to open this up in Nira and check it out. It's a pretty cool data set. Next up, the system now splats, right? You gotta splat. It's 2025. Everyone's got to be splatting something. And so in this case, this was in Toronto, I think, the Daniels Building, beautiful structure. And here is a picture of your setup. Is that also where you started the scan, Cody? You started it from the sidewalk here?
It is, yes.
Gotcha.
Yeah, so started it from there, walked around the building, did one single loop in front of the building right there to get
Mhm.
this the front face of the Gaussian splat. The key design for this building, or the reason why I did this scan, is because on the front side of this building, we can see that this was older, so it's a 1800, 18 like 60, 1870 build, and on the back side of this is a building that was merged with it that's around 2011 or 2012 build. So I really wanted to highlight with the X4's handheld the ability to capture old structures for that concept of historical restoration or preservation, and also new age structures for as-built models and anything of that nature. So
Yeah, it looks great. It was a rather short scan from what I can tell, and that's that's the beauty of these handheld slam splat systems is it can be short or it can be long. It's really just how much do you want to have in the final PLY point cloud essentially. This was I saw 700,000 splats. Actually a fairly low number, I would say, from what I come across generally. At Nero, we started supporting splats in our viewer recently, so I've seen a whole gamut of different input data, and these splats are often produced from just photos and trained for very different amounts of time, and sometimes they can be really gigantic and almost not serve any reason to be that big in terms of how dense it is. And in other cases, it can be kind of like this, where I think this is kind of like a sweet spot. It's just enough, not too much. You get a really good representation visually of the structure, and of course, it's measurable because it's backed by a point cloud that was collected in the SLAM configuration. Looks awesome, and the image quality is good. For people that are sort of learning about splats, the I think the single most important thing to creating good splats is good image quality and especially exposure. If you see like those floaters around and like these like weird artifacts in the point cloud of the splat, it's typically related to just images not being exposed evenly throughout the sequence that they were captured in. So what I see here is that the image quality from these cameras that you guys have on the X4 is consistent, and the color grading is realistic. It's not too vibrant. It's nothing too flashy. It just works well. That's really awesome to see the proliferation of these handheld splat scanners. I think I called it like 8 months ago when I first saw it, and like everyone's going to start to do this because it's awesome. Like it's just another layer of information that has very few downsides. All
yeah, those
right.
results were generated from LiDAR 360 MLS. So
Mm.
we also jumped in on the Gaussian about 4 months ago, 5 months ago. So our results will only get better from there. And as cameras also improve as well, the results collectively from Gaussian is just going to continuously exceed what we have seen in the past.
Yeah, it's gonna continue getting better, absolutely. In terms of like that post processing you just mentioned, so there's a few pieces of software that Green Valley has available for different use cases, and so there's MLS, which you mentioned, so LiDAR 360 MLS. That's for mobile laser scanning, so more like vehicle based scanners, right? Like the heavy duty, like big multiple scanner heads. You're driving around the city, and this is like urban development stuff. A lot of high quality, large point clouds from the ground. We won't talk about that. We're going to be talking about LiDAR being processed in LiPowerline. But another piece of software that I use a lot is LiDAR 360, which is kind of, I think it's like your original software from GreenValley that does all sort of the mapping use cases. So when I use the Wingtra and its LiDAR for mapping work and even for anything related to photogrammetry, you can throw that into LiDAR 360, get it processed, cleaned up, classified there. And then outputs from there as well, things like contours and tin surfaces. And then LiPowerline is like a different flavor of LiDAR 360 that's purpose built for the power line industry, which is really cool because it guides you through the process from kind of my vibes of using it. and it doesn't expose things that you may not need to use at all. So it's not like the traditional big bloated app with everything, but you can switch between them. All the files and everything that's created in LiPowerline is directly accessible in LiDAR 360 if you have sort of like a hybrid project or something like that. Am I right about that, or am I getting that wrong? It was just my vibes from using it.
Oh no, absolutely, yeah. And LiDAR 360 has many tools as well, but both of them generate a live data file, which is our proprietary LAS file. Both softwares also give the ability to convert back to LAS. So if you're going to take the uh, point cloud itself and go into a third-party software of sorts, you can do that along with the several different type of exports from both softwares. So.
Yeah, it's these two have like LiDAR 360 specifically has become the LiDAR post-processing app that I recommend the most because of just how good it is at classification and how many sort of tools it has in creating deliverables. And it's very robust. Like I just did a 9,000 acre LiDAR scan of an airport, and we're doing this for vertical obstruction surveying. And it humongous point cloud, 15 flights, 3 returns on each, just like an incredible amount of data. But LiDAR 360 chugged through it, classified it all, segmented the trees, which is something we'll show you is incredible, and then all the way through to the line work and the deliverables is really cool how stable it is. I can't say enough about how much I love that piece of software, and LiPowerline is definitely creeping up on that list now. One thing that I think is awesome about LiPowerline are these simulations. This, of course, like instantly grabbed my attention when I saw it. I'm like, I need to know how to make these because I just want to have this as my desktop background. It's just so cool. What we're seeing is the wind simulation. So here are in orange, the conductors. And then on this is where you see the lower one, that is the ice simulation, right? So if the line builds up ice, it gets heavier and starts to droop down. And the interesting thing is see these areas near the bottom that are highlighted in red, those are sort of like the danger areas, right? So according to this simulation, there's a chance that if this ice builds up and these temperature parameters you've set, you may have this conductor touching the vegetation or maybe a structure that you see here.
Yes, there's a series of different types of danger point, both simulation and real-time condition analysis that can be run with inside of LiDAR 360, LiPowerline, also LiDAR 360's real-time condition analysis. But one of them or both of them is the future simulations based on specific set parameters by the user, such as ice load or wind speed, among other functionalities as well.
Yeah. And also, since you have all that geospatial information, another trick up its sleeve is the ability to create these pre-planned visual inspection routes. So what you're seeing here is essentially the waypoints that the drone would follow if you loaded up this flight plan and hit go, and then also where it would snap a picture, and you can see that those camera poses are set up so that they line up directly with that element that you're interested in doing that visual inspection of, right? So we have the point cloud, which is great for geometry and structural information, and sort of environmental information as well on both sides of the channel. But then visual, you got to get up close. And so there's multiple ways of doing that, but the same payload being able to generate this and the software kind of packaging up for you, so you just load it in and hit go and do that when you need to, is pretty badass. It's from my setting it up is actually very intuitive. You essentially use the point cloud to click on the areas that you're interested in, or you can automate that because you have tons of different models for towers in existence in North America, all over the world. And then these flight waypoints are automatically generated with the right orientation, the right setup. We'll show that in the workflow video coming up, but yeah, this is pretty cool.
Yeah, it's great because it can easily be exported as a file that can be added to DJI Pilot and automatically fly those with something like the Phantom 4 or the P1, for instance.
Right. Yeah. And I mean, if you're getting that close, you don't always need super duper resolution. That's kind of like the balancing act is like, 150 megapixel camera from far away or get up closer with like a 20 megapixel camera and you have the same image, right? It's just that getting up closer is the tight part, the hard part, and this solves that for you, right? So if needed. The
Yeah.
analysis of these images also happens on the software. Sorry to cut you off, but just to sort of cover that as well.
Yeah, so I was just going to say that with something like the Lyra X4, it can utilize the dual mounted system. So you could have one of those cameras
Mm,
with the Lyra X4 on it. So you can do single flight scans and collect data images at the same time. The X4 itself is able to also automatically take tower images as it's flying if you're doing side following. So you can utilize this together as a system and then go back and produce these trajectories to do a follow up based on what you had done already and the point cloud itself.
hmm. Yeah, and so these trajectories are also GPS positions, right? So these could be repeatable without having to redo all of this work, right? You just essentially do this once and then you just replay the mission anytime you need to do another pass at the same structure.
Exactly. And then you can link the images within the fine inspection tool within LiPowerline so that you can have the exact image location within LiPowerline when viewing those images and also viewing the point cloud together.
Wow, yeah, that is very powerful stuff. Now, how do you do all this? We'll go through the workflow. I asked Cody to put together kind of like a batch of videos showing like the most important features, and we'll play through that, and Cody will explain what's happening on screen. But before we do that, I wanted to just show on my screen what a project like this looks like when it's opened up, and you can see here in 3D I have the tower. And I also have the, actually, let me just hide some classes because that green is very jarring. I'm just going to hide the other line there as well. And you can see here that if we zoom in, you have those camera frustrums, and we even have the simulation. Let me hide the simulations. There we go. This. And then just add the vector layers, and everything is also a little bit too labeled. But there we are. And you can see some profile views here of how it would navigate. Very, very tight up against the structure, not deviating much. So you're gonna have consistent images across the entire line, which is important. It's also important if you're using AI to make some of these identifications, because you gotta kind of treat it as the training set that you used, be as similar to that. And then you can see here again in this point cloud the danger points. You can see this. I think it might be a little distribution pole that's colored in red, right? And when we show the vector for the, let me just hide this. I think it would probably be the ice simulation that picks this up.
I
No,
believe so,
the
yeah.
shield wire. Yeah, pull these out. You can see all the different simulations that I got here. It's within a sort of a threshold that's been set, and that is something that you configure based on your locality, based on your standards, your client needs, and then these simulations are picked up directly from there. And these are shape files, right? So they're instantly accessible in GIS formats as well. So if there is a sort of GIS database that the utility company is using, pretty certain that it's just going to be plug and play for them, and all the coordinate reference stuff is going to play nice. And this is going to be in a very sort of lightweight format for anyone to access and to have on hand. I just think that's so cool.
One of the key things is in terms of the simulation side of things when it comes to danger points. Originally, most of it was geared towards forestry because of the fact that trees are the most unpredictable. So we have simulations within the software that are geared towards tree growth. So we can do an active prediction of tree growth over a certain amount of years. So you know exactly, say in 2 years, that these trees are going to become a danger. The other one is geared towards like disaster response. So you can do tree fall analysis. So if you know the heights of the trees, then we can determine whether or not those trees may become a danger. And so we can also highlight those danger points as potentials that should be either considered at risk or taken care of as soon as possible.
Yeah, here's that tree growth simulation. If you can see, there is the vegetation point cloud there, and then here's the simulated conductor. And this is the high temperature simulation. And so you can switch through them. And if you look at the ice simulation, it's actually even lower, so even more of a danger point. But when we look at these, the way that it's doing this is that it actually even has the tree segmented separately. So here I switched into the view that's called Tree ID, and you can see that each tree is now colorized with a different palette, and we can very quickly understand which specific tree is problematic and deal with it individually rather than sort of like clearing that whole area out and damaging that environment. Really powerful
Yeah,
stuff.
with
And
this segmentation, we can choose the tree heights as well. So you can, in segmentation, predictively plan any tree above a certain height. This one is just at the base default setting, so pretty much at 0 meters from the ground is segmented trees. But you could do it at 5 meters, 6 meters, 10 meters, and then it'll only hyper focus on the ones that are current risks to say a high metered power line, or if there's low distribution lines, you can focus on lower trees as well.
I'm gonna see if we can get a profile here of these trees because this is an H600 data set. So you're also going to have a ton of penetration and you're going to have the ground segmented as well, which is important because you need to know where the ground is to even figure out how tall each tree is. And that may be a differentiator of what type of tree it is and how sort of mature it is today. And so the classification always becomes the one thing that you have to get right or none of this really works out. And so having the classification aided by AI and then of course like a human quality control pass is always going to be part of that process. But that really, really simplifies the entire procedure. All right, so that kind of gives us an idea of like what the end deliverable could look like and sort of the steps behind it fall in this. So we'll start with the tower marking. I'm just going to play this. This is just a screen recording from your side that you sent. Let's make this big. And yeah, walk us through what's happening here.
Yeah, so there's a couple different functions within inside of LiPowerline for tower marking. We do have auto extraction of tower points. You can also load in a preloaded tower file. So something like the X4, as I mentioned, is able to generate those tower points along the way. You can preload in that KML and it'll automatically mark those towers based on that location. But in this case, I was just highlighting the manual tower marking. So I manually clicked on the towers and then chose the type of towers that they were. This allows the software to know exactly what the tower is, what type of voltage it is, and this determines how it goes about both the classification side and also the insulator hanging side.
Yeah, and so you can see here, in back to the app here, you can see this little red dot here with the number 2. It's a little bit harder to see. Let me just switch everything back on. Maybe this will help. There we go. So you can see this dot. This is just like a coordinate essentially that says this is the center of the tower and this is the height of the tower. Do you have to be like super careful with this? Like, what if it's off to the side a little bit? Are you gonna break stuff, or is it going to kind of correct for you when you get to that situation?
It actually automatically chooses the center point. So you just have to click on the tower itself and it'll choose that center point.
Wow, yeah. That's the benefit of having, such rich information that's contained in a point cloud. This isn't really something you can do with images, right? Like images are, they have cameras, distortions, you can't really pinpoint things directly as quickly. But with LiDAR, you have that flexibility, and then sort of the AI behind it is actually not all that complicated, and it's amazing how it's been productized so quickly. So that's the tower marking. And of course, if you need to mark a lot of towers because it's a long line, then the automated features are going to, again, come in pretty clutch because you're going to save a lot of time doing that. Next up is classification. So you mark the towers, and then now let's go and classify. I'm just going to pause this here so we can see some of the settings. Do you want to kind of walk
Yeah.
through what's going on here?
Yeah, so I mean, you pretty much just load in the point cloud, which it automatically does when you do the clip and classify button. It gives you the ability to clip the point cloud based on a certain buffer parameter, and then also the classification. So in this case, we can preset what we wanted to classify. I had it set with shield line, insulator, and drainage thread, scissor crossings, up and down, similar to what we were talking about with
Hmm.
the X4 earlier.
Hmm.
And then also noise, because if there's additional noise, we want to be able to classify it and easily remove it. And then buildings, for instance, if there is ones that may be potential danger points, it's better to have those classified. And
Yeah.
then other lines, such as auxiliary lines or also distribution lines. If we're looking at transmission lines, we don't want to focus on the distribution lines. And
Hmm.
then also water and highway, and then a collection of other classes can be added here as well.
So essentially, you're telling it how to classify and also clip. And the clipping is important because your point cloud may have points on the periphery of the line that aren't useful for any reason, right? It's just too far away. There's really no way the simulation is even going to be able to make use of them. So why keep them? The clipping kind of takes those tower positions and creates this corridor with the width that you set. And then it classifies only inside of that corridor of remaining points. And it classifies what you have checked off here. So I see like highway and water isn't checked off because that's not in this scene. But if you had a more urban area, you would want to check those on and then tell it how to classify those as well. Awesome.
Exactly.
This is probably previous to having something automated. This is the most time consuming part of the post processing workflow. And so, like for me, I would never want to be just doing a full time job of classifying point clouds. Very, very painful. But this handles it for you. It's actually really fast as well because these point clouds and the scenes that you're capturing are narrow and long, so the actual point cloud quantity is pretty limited. Like you don't need to do the 9,000 acres I talked about, and it's also looks like it's specifically trained on power line data because it segments between the conductors, the insulators, the towers, all of these sort of different features that are unique to T&D, and you won't really see in regular aerial LiDAR.
Exactly. Yeah. So LiDAR 360 classifies in an approach at a mapping level. So it classifies everything. LiPowerline can classify everything, but its hyperfocus algorithms are geared towards power lines.
Yeah, here's another algorithm. This is the interactive patch tool. So I remember earlier we were talking about how sometimes if you are maybe too fast or too high, you may have parts of the conductor line that it hasn't been captured completely. There's gaps in between it. And so you guys have this interactive patch line tool that essentially fills in those gaps where you select it and ask it to.
Exactly. The software generates points, and those points can be merged to the actual existing point cloud. So after the patch is done, it creates a seamless line, which makes vectorization 10 times easier without issues, allowing for AI to take over and make things much easier for the end processor.
Right, right. So that's like a rescue button, essentially, if the data set came in from the field and it's not optimal and you're not going to be able, it's not going to work if you just hit go. All right, next one, hang insulator, auto hang insulator. So what are we looking at here?
Yeah, so one of the biggest things with LiPowerline version 4, which was previous to this version, was people had to manually hang the insulators. That also means you needed to know exactly what the tower was, what type of
Mm,
insulator. So now we have the ability to do auto hanging, both of straight towers and tension towers. So it will hang the tower specifically geared towards that type of tower and do it automatically. And that goes the same for if it's 100 kilometers worth of towers, it's going to automatically hang those insulators, which in turn makes it so where the next step, which is the vectorization, is much more seamless and easy to do because it's based on the location of the insulators.
got it. So hanging insulators, what does that mean? Because some of these terminologies are a little bit very, it's like specific to utility world. Does that mean like classifying those insulators, which is sort of what connects the conductor, the yellow wire to the tower, is just making classifying so that we know that's insulator?
So it's actually during classification. So the first step, it classifies the insulator, which is that part that holds the conductor to keep it safe. It classifies that automatically. So in this image, you can see that there's purple hanging down from the
Mm.
towers, each of the towers. Those are the insulators. It uses that classification in order to hang vectorized insulators. So
Oh,
these insulator files are actually saved as shape files. So you have the exact location and details about these insulator files once you do this auto hanging, or you can do manual hanging as well. But auto hang saves a bunch of time, and it saves it as a text file. So you have a text file with the locations of these insulators. So for fine inspection purposes, you can also utilize that insulator file to produce those waypoints as well.
Gotcha. So the points here on the insulator, they've already been classified as the insulator, and then now you're vectorizing just that specific segment with the sort of special attribute that the software can then make use of as, hey, this is where I attach the vectors of the conductor to.
Exactly.
Cool. And so previously, you had to go through all of these manually, like click, 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 click.
Hmm.
Yeah. Okay.
Yeah.
Yeah. Don't.
Yeah.
Not interested. Not opt
Yeah,
out.
yeah,
Opt
yeah.
out of
I
that.
give major credit to everyone in the power line industry that has been able to do this within software for a long time. That's a headache that I cannot imagine.
Seriously, yeah. The more I learn about this side of the capture business, the more respect I have for the people that have been doing it for a while, because this stuff is it gets pretty gnarly. Like it's I mean, power lines are cool for like an hour, but then if you're looking at power lines every day, 5 days a week, you probably aren't too happy with your job. So the next step here that I opened up is the batch conductor vector. So now we're essentially drawing those vectors on the conductors. Is that right?
Exactly. So this version of LiPowerline, when we added AI into it, our hyper focus was, which was based on what you just said, which was making the user's day a bit better, a bit easier, a bit more reliable, and making it so where they can be much more efficient. Most like the U.S., for instance, we have hundreds and hundreds of miles of single power lines. It is a hassle to try to go through and manually vectorize these lines, but you need to do that. So making or adding AI to make sure that these things are done as accurate and as quickly as possible was the key push with the latest version of LiPowerline.
Yeah, you said hundreds and hundreds of miles. It's probably like in the millions because it's absolutely it's everywhere, right? Like anywhere there's power, there's got to be lines taking it there somewhere. And like you
Yeah,
hear all the wildfires and the stuff that happens during the summer is usually because of situations where this information wasn't available to the utility company, right? They didn't know where these danger spots were because they couldn't go through all of the network that they had.
exactly. So the side of fine inspection and truly understanding every bit of asset that companies have and states utilize is a huge factor. So we need software like this to make sure that those are done in a timely manner to prevent future disasters from occurring.
Cool. Well, we're about to approach an hour, and Cody and I decided that we're just going to keep going because this stuff is really cool. And so, if anyone needs to go, we're going to have a recording available for the remainder of the event as well. It probably is still just going to stay live. You can stick around, or you can catch the remaining section where we continue going through these workflows. But real quick, I just wanted to say here in this batch vectorization. We have a start tower index and an end tower index. So I mean, this could be like if it's like 1 to like 100 because you have 100 towers in the data set, it's just going to go through and do all of those sequentially and automate the vectorization of each conductor, there may be like upwards of 12 per tower, but it's just going to do that all in one go, right?
Exactly. And as you can see at the top, there's several different vectorization features, single, multiple, batch, the shield line and vector line as well. So there is much more to the software than we'll be able to highlight in this webinar, but the key functionality is the autonomous side of making the job much easier for the users.
Yeah, and like the data seems intimidating. Like when you see like all of these menus and stuff, seems really like, oh my God, it's gonna take forever to learn this. But what I find with the GreenValley software is that if you work your way from left to right, you're usually gonna end up in the right spot. Right, so it's kind of sequentially set up. You're going to start with clipping and then classification, and then you're going to start the vectorization. You click on this button, and then that opens up these options, and then you select, do I want to do one at a time? Do I want to do batch? Or maybe these other additional options, and you just sort of work your way across, and you won't miss anything. You don't have to sort of know shortcuts or remember sort of menu items and go and click through them that way. So it makes it really, I think, pretty easy to train on. And I've trained several people in organizations on LiDAR 360 because of that, because I find that it's just very easy to teach how to do it because it's visual and it's very well sort of organized with these ribbons at the top.
Yeah, we even have both in LiDAR 360 MLS and LiPowerline. We have a pro and a basic mode. It's automatically added to the software. So when you open up LiPowerline, it asks you if you want to use the professional or the basic mode. In the basic mode, it pretty much sets up with check marks the key tools that it'll utilize with one single run button. So you can just hit run and it'll run all the key tools to get something like auto vectorization or batch extraction and things of that nature.
Yeah, awesome. So here, oh, actually, one I saw this. I just want to call it out. So I think this is the old school way of doing the shield line. Shield line is that top wire. It's not a conductor. It doesn't really have electricity passing through. It's just there to sort of protect the wires underneath it. It's an important component because it's there for a reason. So we have to vectorize it. But the 3 points fitting single shield line, that was like the manual way of doing it, right? Like you would probably click on the top here, the top there, and maybe the lowest point on the hang. And then it would kind of blend those through in a parabola. But you're doing the batch fitting here, which is again just like the conductors, where it's looking through all the towers that you ask it to, 1 through 6, and it's going to automate that across because it knows where the classification of the points is, where the hang is, the tower is. All of that stuff is there, which is really interesting how it kind of builds up on each other. And again, it's all building up kind of left to right on this side too.
Exactly. Yeah. The single fitting or the manual fitting, it still uses traditional arc methods. So it's automatically, snapping onto the vector itself or snapping onto the point cloud to do that line fitting. But again, it takes a lot of time. Key functionality is if you got a short amount of or a small amount of lines, or if there is errors within the automatic classification, which may happen, or within the auto vectorization, you can easily go in there and fix those by running that single batch.
Sweet. Next one I pulled up is the wind simulation. All right, now we're getting into those simulations with the vectors and then sort of the what could happen scenario. So the first screen you see when you click on that, so it's going to be under the simulation condition ribbon menu here, and then you see here we've marked the towers, we've clipped and classified, and we're going to done the vectorization, and then we're looking at the simulation, which is right here in early warning analysis. We have the weather simulation that's like ice and wind and heat, and then we have tree growth and tree fall that you mentioned. Is there another one here we're not seeing directly that's maybe buried a little bit?
Yeah, there's in terms of simulations, you can run the real-time analysis. So you can do real-time analysis of current danger points and then run simulations based on those danger points as well. So there's futuristic simulations just based on the
Mm,
point cloud, and then there's also simulations based on already existing danger points or scissor crossings, things of that nature, that aren't shown directly right here. They're actually in one of the tabs that we can see there. And I think one of the few things that I didn't pull up in videos was like tower inclination and tower nominal height. Just being able to get detailed information about the towers themselves is also part of the simulation side of things so that you can actively predict certain situations with towers.
right, and that's usually information that you're going to have, like the utility company is going to have, and you're going to sort of configure this and set it up initially with all those things in mind, and then once you have that in there, you kind of just repeat the steps. You don't worry about those because it's going to match the conditions in the real world. I see here that we have power lines, shield lines, and drainage threads. We can do simulations across these three. And then you can see even the voltage level, the line type, all of that is configurable. And so that it's a simulation that is as, catered to the equipment and to the assets. And then you're adding these insulator files and vector files where it's eventually ending up. And so these files are things that are already sort of ready for you, and you can adjust and to your geography, to your localization, and it's picking up that metadata in those files, I'm assuming.
Exactly. So the insulator file is actually the one that I mentioned earlier that's generated when you do the auto hang of the insulators. It
Right.
utilizes that to generate the simulations.
Very cool. So you're loading those up, and then conditions. Here's what you can adjust. So the wire temperature, right? That will cause it to expand or contract and sort of sag more or less. And then the conditions that you are simulating. So how it was captured and where you're going with the simulation. And then there's additional parameters here. You change the wind speed, for example. You set that wind speed to 10, so you're simulating wind speed and ice thickness build up at the same time, and just hitting start. Of course, like you probably would want to change the temperature. I don't think the wire would be 50 degrees Celsius if you're got ice and wind on it, but these types of things you can run multiple iterations if you need to, and kind of have a set of scenarios planned out. Pretty cool.
Yeah, that's the key factor, is that just highlighting that pretty much an unrealistic situation can also produce results. So a realistic situation for this use case, I was like, I'm going to use the unrealistic situation because it's going to prove that those results are as reliable as it would be if we actually did the correct wire temperature at the time.
Yeah. And then here you're setting up essentially the results to be output directly into like a document report with all the screenshots, all the sort of the visual information done automatically. It's really complete. Like it's very intense. We can probably have some of those to share along with the data sets after this. But it's fully compatible, I think, with what the industry is kind of used to seeing. And it's not something that you'll have to reinvent the wheel on when the end user looks at it.
Yeah, the level of reports is ever growing. So the amount of features and attributes that we are adding to the reports is growing as well. So each of the reports obviously is the key factor of the end deliverable for most cases. So we do highlight that each of the reports can generate based on the specific need. So
Yeah, and this is super important because just the amount of assets that have to be covered. You got to be organized, and this isn't just a map here, a map there. This is very, very tied information with the general operation of the network as well. This one is that fine inspection. So this is how you're setting up the visual flight plan, right? So you have a tower model here that kind of tells you what you could go and visit, and you just then snap onto the point cloud with a click where those locations are. And then you can automate this as well, I believe, right? As long as you have the right sort of tower type and it matches what the point cloud is.
exactly. So yeah, what I was showing there is that at the first point, you can select on each one and choose a specific point. But then I just ran the automated, which it'll automatically run each of those points.
Yeah, and then you set up what drone you're building the mission
Yep,
for, and then boom, the DJI pilot essentially file gets spit out, and you just load that up on your controller and go.
exactly.
Cool. And then the last one is the fine inspection channel trajectory. So fine inspection, you guys call it fine inspection, but I think another way of thinking about it is just like RGB inspection, visual inspection. Fine, I think, kind of means like closer and more detailed. What is a channel trajectory, though?
So this is just pretty much like a follow-up trajectory that you would do. So
Oh,
it's the presetting the trajectory so that it's the exact same trajectory that you're running that you did the previous time to get the point cloud in the first place.
right. So
And it's
this
generated
is
based on this.
got it. So this is what I'm seeing here. This is like once it's finished up that inspection of at the element level on the sides, etc., then how to get to the next tower, and then
Yep.
repeat that. Got it. Very
Exactly, yeah,
cool.
because you want it to be able to just continue on with each of
Yeah.
its scans. Because the in that setting, like if you went back a little bit, you could see the list of generated trajectories. One of those is the surrounding one. So if you want to do a full surrounding trajectory, you can fully surround the trajectory of the tower itself and get a different type of scan. So you want to make sure that each of the trajectories in between them are chosen. So you use the channel trajectory and then you use the individual
Mm.
tower trajectory, and those can be merged together as a single file for the drone. So say one tower you want to do a full surround, then you can have it that way and have the channel trajectory follow it, and then go to the next tower that you do just an individual scan or an individual trajectory style as the first one we showed. Those can all be put in as a single trajectory file.
Wow. I mean, this seems really well thought out, and I have to say it's probably because the amount of actual T&D utility service that Green Valley does around the world, right? Like this is like these are lessons learned in the field that then are taken and then put into the software that you self-develop, probably to help yourself first, and then it's also a great product that others could use. There's one here I saw generate danger point trajectory. So is that sort of a trajectory to take pictures of the areas that have been highlighted as dangerous? So you have another sort of perspective on it?
Yeah, so it utilizes the existing danger points and does a trajectory based on those.
Wow, yeah, that's really cool. I've never built the trajectories this way, but I think I'm going to give it a shot. I have a Wingtra data set of a long corridor as well. I've been meaning to try this on, and just to see is sort of like where is the point cloud going to be adequate? Can you fly really fast for long periods of time? Like I said, this is like ideal BVLOS work. And as that becomes more of the norm, just by necessity that we need to do this to prevent these forest fires and to keep our grids that are very, very critical, of course, keep them operating at full efficiency. This it's the only way, right? You can't be doing this with helicopters with people on it and putting them at risk and do the same scale. You can do this very efficiently and it's very feasible now with all of these tools and sort of ecosystem to do them with drones. And you're talking about like a crew of one person versus a $1 million helicopter and three people on board flying really close to high voltage wires.
Exactly. And with the advent of something like Starlink, that's becoming more and more realized at a level where an individual can be in one individual spot. And with BVLOS, fly it as far as possible, utilizing something like Starlink. They don't need to actually be there for it. And to be able to get these types of scans, that's why I said like the hundreds of miles. I was thinking of the Nevada desert, where it literally is you could just see it for as far as the eye can see, and it still is not enough for you to be able to continue that line of sight. So having new age communication systems allowing for something like this makes just the users' work and efforts much better and much more safe.
Yeah, and the nice thing is that the locations and sort of like the situation that you're in when you're doing this work lends itself very very well to BVLOS because it's sparsely populated areas, it's very remote. Yeah, you're in atypical airspace because you're so close to these towers. There's no real aviation that's going to be occurring near that to begin with. Everyone's trying to stay away from that area to, inherently. And so it's like the first opportunity for like very wide scale BVLOS is kind of packaged up very neatly in this use case as for T&D, and it's also, of course, very important to get this right and to do it efficiently.
Absolutely.
Cool. Well, I think we'll wrap it up there. Should we maybe see if we have any questions and answer some if there's
Yeah, so I don't yet, not any direct questions here. There may have been some on YouTube or on Facebook. So we can definitely follow up with any of the questions directly. Uh, for any other questions that aren't answered here or future questions for viewers of the YouTube video, feel free to reach out to us at our support email. We definitely want to make sure that we answer those questions. And as you mentioned, that we've enhanced our software over the years, both from user and personal experience. So we definitely take consideration of what users want, including what exports people are looking for, what type of file formats people are looking for, and we try to implement them with each new version of the software. So if we don't have something in our software that is an absolute critical use case for the current workflow, please reach out to us and let us know so that we can try to implement that in the future.
Yeah, and I found Green Valley to be very receptive and listens very well to user feedback because they get it. Like, there's so many situations that you can't, you know, plan for and think about when you're developing the software. It's really those end users that are bringing you all the little nuggets of information that make the product as good as it can be. I also saw that you have a QR link for a trial code. I guess I'm assuming people can scan and give uh, LiPowerline a shot.
Absolutely, yeah. So we've had several people scan the code. I'm not sure if yours actively tracks the code scanning, but yeah, anybody who hasn't scanned it, top left-hand corner, can get you a free trial of LiPowerline, be able to try it out with your own data set. As Ted had mentioned, LiPowerline isn't just for products of GVI, it's for any LAS file that is collected. So feel free to utilize the free trial system and reach out to us if you have any other questions related to the trials. There's also YouTube videos that highlight much of the tools that we covered and how you can utilize them, and the user guide as well if you run into any issues.
Yeah, awesome. And if you don't have a data set to try it with, like I'm happy to provide some that I have, maybe even the one that we collected ourselves with the M400. And it's essentially just the point cloud. The point cloud, even photogrammetry based point clouds could probably work. Like I haven't tried it, but a point cloud's a point cloud. But that would be a really cool test. Overall, though, really exciting sort of advancements in the industry, and it's super, super exciting to see the level of sort of complexity and these exotic sensors making it downstream to us finally, and being small enough to carry on these UAS platforms and to carry for long distances. And yeah, this opens up a lot of opportunities, and not just for power lines. There's a lot of ecology work, a lot of forestry work that's left to do. And overall, you're going to have more options and more choices than ever.
Agreed.
Cool. So I guess we'll wrap it up. Thanks everybody that attended. This recording will be available on YouTube, and I'll share it. So will Cody. And then anything you need from us, please reach out to us directly. I'm just going to pop open Cody's email here. I believe we had it. Let's swap through. There we go. There's Cody's email. And if you have any specific questions, GreenValley related questions, reach out directly to there. Cody is a really great friend of mine, and I think you can tell how passionate he is about this stuff. Like, he lives and breathes it, and he's got the beard going on, beard crew.
Yeah, definitely beard crew. You can't forget the beard. Can't forget the beard, man.
Gotta fit the stereotype. Let's do it.
Exactly.
All right,
Yeah,
Cody.
no, honestly, Ted, it was an absolute pleasure to have you on, man. Thank you again for taking the time, and everyone, thank you for taking the time to be here. We're super thrilled about LiPowerline and the advancements that it's made, and we just want to get it out there as much as possible. So feel free to let anybody get a chance to try it out, because they will definitely be as impressed as we are. And again, yeah, Ted, thank you for your time, and hopefully we can get out and get some scans with the M400 again soon.
Yeah, or anything really. Any field work with you would be fun. So let's plan for that as soon as we can. All right, thanks everybody. Have a great rest of your day, and we'll catch you next time.
Absolutely. Thank you, everybody.